In this video, we are going to solve the apportionment problem using the various apportionment methods. So we have a couple definitions, the standard divisor and the standard quota, and we have some formulas for both of these things. So the standard divisor, you're dividing the total population divided by the number of allocated items, and then the standard quota is dividing the population of a particular group by the standard divisor. So we have four different methods for calculating these apportionment problems. So basically, whenever you want to apportion something, a good example of this would be if you have a lot of computers that you need to distribute. Like let's say a school has like 50 computers that they want to distribute to different campuses. But they don't want to just divide those computers up equally. They want to divide those computers up by the number of students that are going to use them. So that we are going to apportion these computers to the needs of the students and where they need to go. So I'm going to go over each method whenever we get to the exercise. The first method that we're going to be looking at is Hamilton's method. Hamilton's method, we have three steps. We're going to calculate the standard quota. We're going to round each standard quota down to the nearest whole number. And then any surplus items we are going to give one at a time to the groups with the largest decimal parts. So our first exercise, we have a university which is composed of 5 schools. The enrollment in each school is given the following table. There are 300 new computers to be apportioned among the 5 schools according to their enrollments. Use Hamilton's method to find each school's apportionment of computers. So we are first going to calculate each group's standard quota. So the definitions that we need are standard quota and then standard divisor. So we have to have the standard divisor to calculate the standard quota. So in this problem, our standard divisor is going to be the total population divided by the number of items. So whenever we add up this entire row, we get that our population is 10,410. So we're going to take that 10,410 and divide it by our number of items to allocate, which is 300. So our standard divisor is going to be 34.7. So now we can find the standard quota for each school. The first one we are looking at is humanities. The population of that group is 1,050 divided by 34.7 gives us 30.25. We are going to do this all the way down for each school. So after we have found each school's standard quota, we are going to round down to the nearest whole number. We're going to add these up, and we get 298. So we have 2 that we have not used. So we're going to find the 2 schools that have the highest decimal and give them those computers. So these are the numbers of computers that each of these schools will get. Alright, on B, we are going to use Jefferson's method. So Jefferson's method tells us to use the given divisor to find the modified quota. We're going to round down to the nearest whole number. The sum of whole numbers for all the groups is the number of items to be apportioned. Apportion to each group its modified lower quota. So it tells us that the divisor is 32,920. So B says a small country is composed of 5 states, A, B, C, D, and E. The population of each state is given the following table. Congress will have 57 seats divided among the 5 states according to their populations. We're going to use Jefferson's method, and then our divisor is 32,920 to apportion the 57 congressional seats. So all we're going to do is take our population for each state and divide by our divisor. For A, we get 3.83. We are then going to round down to the nearest whole number. B, we get 5.96. C, we get 12.91. D, we get 15.99. And then on E, we get 22.03. And we round down. And whenever we add all of these up, we get the 57 congressional seats. All right, our next exercise, we are looking at Adams' method. So Adams' method, our steps, we are going to use our given divisor to find the modified quota. This time we are going to round up to the nearest whole number, and then the sum of the whole numbers is the number of items to be apportioned. So C says the police department in a large city has 180 new officers to be apportioned among 6 high crime precincts. Crimes by precinct are shown in the following table. They give us that our divisor is 16 and we need to apportion the new officers among the precincts. So we are going to take each precinct and divide by our given divisor. So we're taking each precinct and we are dividing each of them by 16, and then we're going to round up to the nearest whole number. So on A, we have 446 divided by 16, we get 27.875. We are going to round up to 28. On B, we have 526 divided by 16, we get 32.875. We're going to round up to 33. For C, we get 835 divided by 16. We get 52.1875. We're going to round up to 53. D, we have 227 divided by 16 equals 14.1875. We're going to round up to 15. On E, we have 338 divided by 16. We get 21.125. It rounds up to 22. And then on F, we have 456 divided by 16 gives us 28.5, and we're going to round that to 29. We are then going to take all 6 of these and add them up, and we end up getting 180. And that is the number of police officers that we need, so we're good. All right, the last one, we are using Webster's method. Webster's method says to find a modified divisor such that when each group's modified quota is rounded to the nearest whole number, the sum of the whole numbers for all the groups is the number of items to be apportioned, and then we are going to apportion each group its modified rounded quota. So D says a rapid transit service operates 200 buses along 5 routes, A, B, C, D, and E. The number of buses assigned to each route is based on the average number of daily passengers per route, given the following table. Use Webster's method to apportion the buses, and then it gives us a hint. A modified divisor between 55 and 56 will work. So let's just use the divisor 55.5. So we're going to do the same thing. We're going to take the number of passengers for each route and divide it by our divisor. Alright, so our first one on A, we take 1,087 and divide by 55.5. We get 19.58. We are going to round normal. So we're going to round to 20. B, we have 1,323 divided by 55.5. We get 23.83. When we round normal, we get 24. C has 1592 divided by 55.5. We get 28.68. We're going to round it. We get 29. D, we have 1596 divided by 55.5. We get 28.75. and we can round it to 29. And then the last one, we have 5,462 divided by 55.5. We get 98.41, and that rounds to 98. So when we add all of these up, we get our total of 200. So we are good because that is how many buses that we have.